we're going to talk about, web performance, and I gave the talk this title, Revitalizing the Web, because there's going to be a lot of things that I want to talk to you about. And we have, about 50 minutes to cover everything related to web performance, which is, of course, nearly impossible. But I'm going to try to talk about some of the most important developments that you should be aware of in terms of web performance these days. So my name is Tamas. I work as a developer evangelist at a company called Cloudinary. I also happen to be a Google developer expert, and this is why I guess I'm here. And my category is sort of web technologies / performance. I'm also on Twitter, so you see the Twitter handle on this slide. If you have any questions about stuff that I talk about during this presentation, feel free to DM me. Or if you just want to have a chat about some other web technology, I would be more than happy to have that conversation with you. Okay, so the way I kind of structured this presentation is that I have a couple of slides, around 30 slides. Some of them are just one-liners like this one. And then I also prepared a sort of demo application where I'm going to demonstrate to you a couple of things that are going to be relevant to what I talk about here as part of this presentation. So the web is growing, right? That is our first statement. So undeniably, how we use the web itself has seen an incredible growth over the past decade. And I collected a few statistics, and just for your reference, you can find a link to the HTTP archive, which has some very good reports and resources available for you if you want to dig into these statistics. But just consider this, that about 10 years ago, when I think, at least myself, I used the internet 10 years ago as well, in the same way that I use it today. And the total kilobytes for all the resources requested by a page averaged to be 657 kilobytes on a desktop computer. Okay, so that means that pages were around that, had that weight. Now, back in the day, so again, 10 years ago, there were 68 average requests for resources on desktop, right? So that means that there were 68 requests for things like HTML and CSS and JavaScript and fonts and other stuff. Now, compare this to last year, and this is not even a range, this is just one single year. So I'm not averaging 2 years together, I'm averaging 1 year here. 2,042 kilobytes average on desktop and 1,891 kilobytes on mobile, which is a really massive number. The number of resources, not close to double, but we now request a lot of additional resources on a desktop computer, right? So this is, again, remember, this is more HTML, more CSS and stuff. So let's dig a little bit deeper. Again, using the same statistics, and then I promise I'm going to not share any more statistics with you, because this is not a presentation about the statistics of the web, but I want to still paint a picture for you so that you see the sort of transformation the web has seen. I'm pretty sure it's obvious to you, but maybe you haven't noticed the scale. And to me, looking at these statistics, it was very obvious that the scale is just immense. So again, back to 10 years ago, an average page, so now we're talking about a single page, there were, or a single site, it's a site, there were 3 CSS requests, 2 font requests, 4 HTML requests, 42 image requests. And it's really important that those image requests average to 327 kilobytes, more or less, 11 JavaScript requests at 133 kilobytes, and no video, right? 10 years ago, video wasn't a really sort of important aspect of the web. Now, we changed back to last year, so 2020, more CSS requests, more font requests, less HTML requests, maybe because of, popularity of single page applications, less amount of image requests as well, but those images, so instead of 40 something, we now have 26, they average at nearly a megabyte, right? That's a lot of additional resources that now we download. Also JavaScript, right? We now request twice the amount of JavaScript, and it's 450 kilobytes. And now we also request videos, and those are averaging around 1,500 kilobytes or so. Now, what was really interesting, and I have actually I kind of overlaid two pieces of text here, but the amount of video that we request on mobile, so these are for desktop, the stats that you see here, but for mobile, we are actually requesting more kilobytes, which is very interesting. So there's something wrong with how we process and display videos for mobile devices, but that's maybe a separate presentation on its own. So there's no denying the fact that the web has changed, right? So the web has changed and it has grown. How we develop websites have also changed. So if I think about back in the day when I started my sort of career, I was doing LAMP stack and Apache and, writing PHP and just, putting stuff behind load balancers. Then I went to the mean stack, single page applications and, more JavaScript and more JavaScript. And now we have the Jamstack stack and, very interesting developments there. But basically how we create sites has changed fundamentally, right? We now use a lot of JavaScript. We now use media heavy applications, lots of images, lots of videos, e-commerce, etc., etc. And of course, the other thing that has changed as well is how your end users are using your site, right? How your sort of customers and visitors interact with your web application. They are less patient. They are used to sites working really fast. They are just going to leave and go potentially to a competitor of yours if your site is low or if they have a very bad experience. So in light of this, performance of websites and web applications matter, right? It's very, very important to get the site's performance to be top notch, right? You could be potentially losing business, you could be potentially losing sales, losing revenue, losing customers, etc., etc., etc. So I think Google created this, they did some research and they shared a couple of insights maybe a year or 2 years ago about some of the key customers or people who they worked with, and they collected very interesting statistics. So for example, Pinterest managed to reduce its perceived wait time on their pages by 40%, which has directly allowed them to have more signups. So basically there's a correlation between perceived wait time and how many people signed up to their site. Cook managed to reduce paid load by a couple of milliseconds, or 850 milliseconds to be more precise, and that yielded a 7% conversion increase. The BBC found, so the BBC being the British broadcasting company in the UK, found that they were losing 10% of the users every additional second their site took to load. Now, the BBC is probably one of the most visited websites in the UK. So we're talking about a lot of visitors. So not 1,000 visitors per day, but probably 100,000, if not more. And if you think about it, 10% of that is a lot. And they were losing that every second. So basically that means 1, 2, 3, they potentially could have lost 30,000 users, which is a lot, right? Just in 3 seconds. And then, there are some other statistics in here. So the point of all this is that web performance is important for multiple reasons. Now, as I said, I'm not going to bore you with more statistics. There are a lot of research paper out there produced by companies like Google and others. Even if you take a look at some of the Chrome, what was it called, Dev Summit talks, they do talk about very specific use cases for companies that managed to reduce some values in their performance scores that were very bad, and how that yielded some additional conversion, additional sales for them. So, you can do that research, but hopefully you now sort of agree with me and we are on the same page in terms of web performance. Now, the other very, very important aspect of web performance is the fact that it's not a thing that you do once. Okay, so first of all, you need to establish a sort of performance culture, right? So every single department has to be on a board and understand that performance matters. Now, I like this example where you have the engineering team versus the marketing team, because the engineering team is always striving to create applications that work really fast, and then the marketing team comes in, and I have nothing against, any of these teams. So this is just an example. So your marketing team comes in and says, oh, we want to track everything. And they just put, 12 tracking JavaScript files and cookie managers and other stuff to your site, which will slow it down. So, you have to make sure that your engineers understand the need for the marketing stuff, and the marketing people also understand that the engineers are working towards creating a faster site. So you have to establish a sort of performance culture. Once you've done that, it's also very important to think about web performance as an ongoing living thing. So basically you should, run some tests, record what you're doing, how you did that, and then measure the results. And then you have to go through this cycle very frequently. After you change something, you have to, retest it, re-record it, remeasure it, etc., etc. And I really like this tweet from Adi Osmani, and he tweeted this about a year ago. And he said, if you want a fast site, test on slow hardware regularly. Okay, so what this means is that you also can't assume that every single person will have the latest MacBook Pro and the latest iPhone or Samsung device available for them, because that is not the case. That is not a sort of real life scenario that you can work towards, right? So this is why testing on slow hardware, or some device that is older and slower than the top-notch devices, is a very good test. Because if your site or application works in that environment and there are no issues with it, guaranteed that on a faster device it is going to work as well. Probably it's going to work even better. Okay, so just remember this sort of performance cycle that I'm showing to you here. Now the question is, of course, where do you start, right? Well, what can you do? Now, there are a lot of tools that are available for you. Even, I collected a few, but there are others, of course. And, if you're familiar with a tool, you can just use that. But I highly encourage you to take a look at the tools that I'm going to share with you today. And we're also going to take a look at a few of them as part of my demo. Now, generally speaking, there are two types of tools that are available for you, at least these two high-level categories: field tools, and then you have lab tools. So let's start with lab tools. So lab tools would be tools that would measure performance in a lab environment. So it would sort of mimic a network connection. So it's not based on real user data, whereas field tools, on the other hand, is always going to be based on real user data. So real user-centric data metrics that are, representing your actual customers. Okay, so these are two sort of separate categories. Now for the field tools, you may have heard about some of these, but there's things like page speed insights. There's the Chrome user experience report, often abbreviated to as CRUX. There is the Search Console, again that's available from Google, and it also contains the Core Web Vitals report. Now we're going to talk about the Core Web Vitals as well in just a moment, but just know that when I talk about the Core Web Vitals, and if you're curious on how to sort of record and measure those values that I'm going to show you, you can just refer to the Search Console, because that has a report on this. And there's also the Web Vitals JavaScript library, which then, so these three tools are sort of, pre-made tools. You log in, you're at your site, you run the reports, you have a dashboard and everything is done. Whereas the Web Vitals JavaScript library allows you to programmatically add measurements to your application, then collect your own data and your own metrics. And then we also have the lab tools. And I'm pretty sure you've heard about the Chrome DevTools panel, and inside of that you have Lighthouse as well. So these are lab tools because they are not using user data. You just set your network connection speed, and you set a few things, and then you press the run test in Lighthouse, and it's going to generate a report for you, but it's not going to be based on real user data. Then there's also web page test, and there's also a separate tool actually for images. So you can actually see how well your website performs when it comes to media and especially images. Now, out of these tools, as part of this presentation and talk, I'm going to talk about Lighthouse because that's accessible, very easy to use, and that is, if you're new to web performance and you never used Lighthouse, it's going to be super easy to get started with that. So when you create a Lighthouse report, and we're going to run a report together in just a moment, it's going to give you a sort of values that you can run tests against. Okay, and it allows you to select from the following 5 categories: performance, best practices, accessibility, search engine optimization, SEO, and progressive web apps. Okay, you select what category you want to run. So for example, if accessibility is really important for your site, you check that box, generate a report, and then Lighthouse is going to tell you what's good and what's bad about your site in terms of accessibility. Again, if you create a progressive web app, you can just run the Lighthouse specific progressive web app tests using Google Chrome. And once you run the report, you are going to get something that looks like this, which is the result of your report, right? So in this screenshot on the top, you see that I ran the performance, the accessibility, the best practices, and the SEO reports. And then you see I get something that's orange for performance and accessibility. Orange is, I would say, I wouldn't even say okay, it's borderline okay, right? You should always try to aim to see green values in here. So for example, best practices and SEO is all green. So, you can do additional work, and then the report is actually going to tell you what sort of things you would need to change in order to get an even higher score. But every time when you see something that is red or orange, read through the report and then think about what you're going to do in order to be to reach the sort of green status. Now, I mentioned Core Web Vitals a few times, and we're going to talk about them in detail, but just for now, know that Lighthouse or the report that you see in Lighthouse will also incorporate the Core Web Vital metrics, except for one. I'm going to tell you which one that is, and additional Web Vital metrics. Now, there is a difference between what is considered to be a core Web Vital and what is considered to be just, a pure Web Vital. But I'm going to get to that as well. So let's actually see and explore what you see in the performance section, right? So that's this first section in here. So the performance section shows you the core Web Vital metrics. There are 3 of them, and it shows you 2. So it doesn't show you the first input delay. And there's a reason for that, and I'll get to that in just a second. And it shows you additional vital metrics, such as speed index, time to interactive, and others. So essentially, under the metrics, you will see values that directly affect your page load time. Okay, so if you fix those issues, you are directly going to affect your page load time. It's going to be better, essentially. Then under that, so this is still the performance section, right? So you have the metrics. Under that, you have the opportunities, which are not directly affecting your page load time. However, they may help your site to load faster. Okay, and these would be things like serve images in a next-gen format, preloading, pre-connecting to various DNSs, eliminate unused, CSS and JavaScript code, apply compression on the server side to your resources, and that type of stuff. And then the last section on the performance still is diagnostics. And diagnostics, they're not going to affect any of your scores. It's more like, it would be nice if you would implement those. So it's information that is more specific for the performance of your site, not directly affecting your page load times. Okay, so things like effectively utilizing your caches, or the way you load fonts, the way you handle event listeners, for example, for scroll events, and again, that kind of stuff. Then you have the next section, which is accessibility and best practices in SEO. So this is the place where you would see things like security vulnerabilities for, maybe third-party JavaScripts. if your HTML is not structured properly for web crawlers to understand, so right, so your SEO score is not going to be good, so you get a kind of warning here. And accessibility checks basically go through your site, bearing in mind what would happen if someone would use, an assistive technology to browse your site, for example, a screen reader, and it gives you sort of suggestions like, hey, you don't have an alt attribute for your image, therefore a screen reader or a person using any assistive technology will not be able to know what image that is because there's no description for the image, that kind of stuff. Now, I kept on mentioning core web vitals, and let's now talk about those. I don't know how many of you, heard about core web vitals or you know the story, but essentially, I think it was last year when Google made an announcement that core web vitals will play a critical role in determining search results. Okay, and if you take a look at documentation on how to appear in the first page of the Google ranking, there's a bunch of criteria, like you have to serve it over HTTPS, you have to have very relevant content, you have to have very fresh content, and there's a bunch of criteria. And Google is going to flip the switch, I think, this spring. I'm forgetting if it's March, April, or May, but it's in that time period, they're going to flip a switch and they're going to say, plus, on top of all these things that we look for websites to determine our ranking, core web vitals are going to be a thing as well. So if you don't optimize your site for the things that I'm going to point out to you now, you're going to potentially lose your ranking results in search. Now, the one critical thing that I would like to mention is of course, content that is very specifically searched for. So let's say I put GDG West Sweden meetup into my Google search, there's only going to be a potential match for that type of search, right? So Google is still going to rank you high enough regardless of your core web vital metrics. However, when there is an ambiguity in the results or there are multiple results, so for example, I'm looking for the best sports car, which could give me 100,000 of results, then the core web vitals metrics will kick in, and the higher or the better you've optimized your site for the core web vitals, the higher ranking you're going to essentially get. So core web vitals, there are 3 of them, categorized into the following categories. So there's loading, or essentially how fast your website is going to load, and the metric that is relevant to that is called largest contentful paint, or LCP. Then there's the interactivity factor, so how fast your users can interact with the page, and that is called first input delay, or FID. And I put a note in here, but I already mentioned that when you run a Lighthouse result, the first input delay is not a metric that you will see, but you can use the total blocking time value, which is a close proxy to FID. In fact, if you fix your total blocking times, if you manage to make it better, your FID is also going to get better. Okay, so there's a relevance between these 2 metrics. And the last sort of web vital is visual stability. How much the content on your page sort of jumps around. Okay, and to measure this, they are looking at this sort of metric that is called cumulative layout shift, or CLS for short. So we're going to take a look at these individually and understand a little bit about them and what they do. Excuse me for a sec. So largest contentful paint is the first one. On the right-hand side, you see whether the metric itself is measured in the field or in the lab. So largest contentful paint is something that can be measured on the field with real user data, and in the lab, like in Lighthouse, okay? So very simply put, largest contentful paint says, how long does it take, as in how much time does it take for the largest visible element on my page to appear. And the key bit here is that it's a visible element. In other words, they're looking for elements that are above the fold, that are visible in the viewport when you load the page. And to narrow that down, the elements that they're looking for are images, both in, as in an IMG tag or an image element inside maybe an SVG, a video element, but only if the video has a poster attribute. So without a poster attribute, they're not considering video. Elements that have a background image via the CSS property of a URL. And last but not least, block level text, so paragraphs or span elements, right? And they're going to take a look at, which is the largest, how much time did it take to load, and then based on that, you're going to get a value. If that value is less than 2.5 seconds, you're good. If it's between 2.5 and 4 seconds, as you can see on the side, that needs improvement. Anything beyond 4 seconds is classified as poor experience for your users. Okay, so that's what you need to bear in mind. Then we have first input delay, and you can see the first input delay is measured by field data, or measurable by field data, measurable by real user data, and it's not measurable in the lab. The reason for that is because first input delay can vary highly based on certain conditions. So for example, if a user accesses a page that requires login and has a customized dashboard, there's no way that you can replicate that in the lab. You need field data. You need data from those users who have logged in, and you collect that data, and then you will determine what this first input delay is. But again, simply put, first input delay is the delta between an input event. So when someone, touches something, like wants to press a button on the screen or click a button. So it's a delta between that time when they touch their device or click, and the time when the browser started to process that request. Okay. And this is trying to make you think about not blocking the browser main thread. Okay. Again, they set up a couple of values. If your sort of first input delay is 0 to 100 milliseconds, you're good. 100 to 300, you need to start to think about what you're going to do. Anything beyond 3 seconds is going to result in a poor first input delay. Now, there's one more note here that, I said a sort of input event. So it's not just event listeners that you need to remember. Tapping on form elements or tapping on links are also considered as sort of events that they measure for first input delay. So a very simple site that just has an input box to type in maybe your username. And if you tap it and there's no sort of, your keyboard doesn't show up on your mobile phone, for example, on your desktop, you can't actually type something into that input box using your keyboard. That is considered to be a bad experience, and you're likely to get a very bad first input delay score. So you have to make sure that if there's an element on the page, a text box, people click it, they can start using it within 1 second of tapping it. Okay, that's pretty much first input delay summarized. And last but not least, cumulative layout shift, measurable both in the field and in the lab. And I put how much a page jumps around. And I was really inclined to put House of Pain jump around theme behind the slide just for fun, but I kind of killed that idea. So literally how much your content shifts on your page is what cumulative layout shift measures. Now, there's some mathematics involved, there's some calculations involved. I'm not going to get into that, but they calculate, how the height of those elements, how much they shifted, etc., etc., etc. Based on that, based on maths that you can read on Google's website, they come up with a value. It's either good if it's, the layout shift score is between 0 and 0.1. 0.1 to 0.25 needs improvement. Anything above that is poor. Let me go back to one slide because I forgot to mention something here. Again, as part of the Chrome Dev Summit last December, Google has announced that the way they're going to update the Core Web Vitals is that every year they're going to make changes to it, and those changes are going to be very clearly communicated to the community. But they also said that there's going to be slight adjustments in the Core Web Vital metrics based on feedback that they have received so far. And one of the potential modifications is going to affect first input delay. So they are thinking about actually reducing the good value from 100 milliseconds to 75 or potentially to 50, which means you get 50 milliseconds to respond to events based on user interaction. Okay, so just bear in mind that. So if your first input delay is in 250 milliseconds and you think, well, that's orange, that's good enough, just know that maybe in 6 months it's going to maybe fall into the poor category. Right. So cumulative layout shift, how much your content moves around. And I added one more thing because I think this is important because, I mentioned how much JavaScript we use these days. There was a very good talk that I really enjoyed. And again, I recommend that you take a look at that from Chrome Dev Summit last year. I think it was titled Modern JavaScript. And I couldn't have agreed more with that talk. When you write JavaScript, and I'm just assuming that people attending this presentation know JavaScript, but if you use JavaScript, you heard about ECMAScript 2015. There's the arrow syntax, there's the const keyword, async await promises. There's lots of new stuff that you can use in JavaScript. Believe it or not, and again, there are lots of statistics about this, but believe it or not, about 95% of the browsers being used today fully support what we deem modern JavaScript. So all the arrow syntax, all the const, all these, ES 2015, 16, and 17 syntax is supported by all the browsers. So one thing to ask yourself is, do you really need to transpile your JavaScript code? Do you really need to create bundles for your JavaScript that you've written? And there are, again, lots of articles and lots of tools available, but you can check your bundler and transpiler and make sure that it doesn't essentially create a bundle that has a lot of additional lines of code that is absolutely unnecessary to add in today's web ecosystem. And one example that I created, and I didn't even know how to fit it to the slide, is that the code that I've wrote, which is 4 lines and 115 bytes, which is just a promise, and it just resolves to something, got transpiled down to that many lines of code, and now my JavaScript bundle is 1.7 kilobytes for no apparent reason. The code that you see on top can be executed in about 95% of the browsers that are being used today. Maybe that's enough, right? So just think about this. And I added this as a one more thing because I could talk about this again for probably another hour. Okay, so what I'm going to do now, I'm going to go to my code editor, and I'm going to show you a couple of examples and demos. I think I prepared about 3 of them. So let's exit this, and I'm actually going to change the theme here real quick because I want you to see it. I generally get the feedback that light theme is better visible on Zoom. So how should we do this? Let's go sort of backwards, okay? I created this, and let me probably zoom in a bit more for you. 5. Okay. So I created this, right? You've seen this JavaScript file before, and then I took 3 sort of popular JavaScript transpiler and bundlers and played around with it. Now, there's a website which I may have forgotten to link in my slides, but I'll put it here. It's tooling.report, which is a very good page that takes a look at, and I can probably open it and we can take a look at it together. Bring it up here. So it basically takes a look at the most popular JavaScript sort of bundlers and transpilers like Browserify, Parser, Rollup, Webpack, and it runs a couple of tests against it. Like, you know, whether it supports code splitting, hashing, importing modules, whether it has, you know, ES, whatever support. So you can take a look at this. And so based on this, what I've done, I took this code and I ran it through a couple of transpilers, and Babel was one of them. And I just configured, you know, a very typical Babel setup, which is actually following their documentation, which is this preset environment. And that, believe it or not, generated this for me. This is now the 117 kilobytes of JavaScript that got generated for no apparent reason. Now, Rollup, so if I just regenerate this with Rollup, is wrong folder. There we go. So Rollup and rollup.config. So Rollup is going to add only a few things to my code because, you know, I didn't specify that I need ES5, etc. I just said, you know, a couple of options, create bundle and make it a UMD, universal module loader. This is what it did. You can pick any other formats in here, you know, common JavaScript, etc. But what matters is that it doesn't replace this bit of code because it understands that this is modern JavaScript. So it doesn't get replaced with a lot of code that Babel did. And the same is true for Webpack, right? So if I do the Webpack, not the installation. It's not here, but Webpack should just do it. No, okay, but just know that Webpack does the same, right? So it would create a bundle which will be very small. It doesn't, you know, overwrite promises async away because again, it understands that this is modern JavaScript. Also note, I'm using the latest version of Rollup and the latest version of Webpack and also the latest version of Babel, but now you see the differences in here. But let's talk about something other than this JavaScript. So let me go to this core Web Vitals folder where I created a sample application, okay? It's an index file. It's going to be a sort of a sample e-commerce application. And what I'm going to do is go to the dist folder and just serve this up. And hopefully this is going to open the web page for me somewhere. Here it is, wrong screen, of course. Right. So typical e-commerce product listing page, right? So you have a bunch of products, you know, sale, search, and nothing works on this page. This is literally just a true single page application, we should say. It's one HTML file that I prepared. So let's do the first thing that you can do here. And I'm just going to zoom in so that you see what I'm doing. And I'm opening my Google DevTools here. And notice that under that, there's this thing called Lighthouse. And I checked performance and best practices. Okay, these are the tests that I would like to run. I can select whether I want to run it on mobile or on desktop. Let's go with desktop. And I'm going to hit generate report. So Lighthouse is now going to analyze this page, and it's going to give us that result that I've shared with you in the presentation. And you see that the performance is red, it's 96, okay? And if you recall from the slides, I mentioned to you that there is this first section, which is the performance. In the performance section, I get some of the core Web Vital metrics, like the, the largest contentful paint, 4 seconds, that's red. Cumulative layout shift, 0.11, that is also orange. Total blocking time, which is the proxy for first input delay, super red, okay, something's wrong. Then I get opportunities, as I said, these are suggestions that don't directly affect the performance score, properly sized images. Then I have diagnostics, image elements don't have explicit width and height. So there's lots of sort of action items that I need to take. And then of course, best practices, you can take a look at the audits, but most of them, actually all of them in this case, are passed. But this is where you would say, images with correct aspect ratios, or, use images in next-gen formats. And this is where that information would be added. Now you come here, and this is a good start, right? This is telling you that something is wrong with your largest contentful paint, something is wrong with your first input delay, and something is wrong with your cumulative layout shift. There is another tool, however, that I would like to show you. Actually, two more. One is a Chrome extension. Okay, I don't know how much that is visible. It's called Web Vitals. So Web Vitals Chrome extension, which is something that you can download from the Chrome store right here. And what it does, it basically gives you this little box here on the top of your, or next to your address bar in the top of the browser. And it's going to be either green, orange, or red based on the overall Web Vitals experience that your site is providing. So if I refresh my page and I try to click in the search bar, notice I can't. So there were a couple of seconds of delay. And if I hover my mouse over this and click on it, I can see that the first input delay is, I can't see it if it's orange or red. And there was a layout shift as well, not really bad, but not good either. So the first input delay comes from the fact that, and again, I'm not sure how visible this is. Maybe I should zoom in on here as well. But the search is not something that I can click for quite a few seconds. So if I just refresh the page, notice I'm clicking and now I could write. And this is in fact the metric that is being measured by first input delay. Also notice that if I just refresh the page, the page jumps because the sale banner comes in. And this is also what causes the cumulative layout shift to be in the red. Now, how can you fix those? So if you go to the code, I created this demo purposefully and I messed things up, right? So for example, in my JavaScript, I just have a Fibonacci number calculation. Why do I have a Fibonacci number calculation? This is to mimic something that is blocking the main thread. Okay, Fibonacci calculation, it's a mathematical calculation. It uses a CPU. There's no way that JavaScript can sort of, put it into or move it from the main thread. It has to basically come to this line and calculate it, and it cannot do anything else. And I can't listen for events, for example, right? I can't click in the input box because my page is being blocked by this calculation. This is not a realistic scenario, of course, because you're not going to have a Fibonacci calculation on your page, but you could have something else that is blocking the main thread. And I've also, took these sort of the template for the watch, and I sort of dynamically load that into the page. So that's why you see, if I go back for a couple of seconds, that there's nothing, and then the sort of watches start to appear. But how can you not necessarily debug, but how can you investigate what's happening on this page? You can use the performance panel for Chrome, and you can just run a profiling for the performance. And as of the latest versions of Chrome, the profiler is also going to show you your core web vital metrics. Now, I appreciate that this is fairly chaotic at first, but once you figure out and try to use this tool, it's going to be immensely helpful for you. First of all, notice there are these things like the first contentful paint on the timings, and on the very right-hand side, I have the largest contentful paint. So I can click on it, and this is going to tell me which element was considered to be the largest visible content that got measured for the largest contentful paint. In fact, in this case, it's just one of my, I think it's the first watch here. And if you hover over it, you see that the element is actually highlighted. So it's really useful. Another useful thing is under main, you can see the tasks that took a lot of time to execute. Okay, so here's one task, here's another one, and a bunch of others. But this is the largest task that we have. And notice, oopsie. And notice here, it is the Fibonacci calculation, right? This is a recursive function. So it calls itself about 40 times to get the 40th Fibonacci number. And this is what's causing this task that is also flagged as a long task in the performance panel. So looking at this, I can say, well, there was a really long task. What is it? Oh, this is the function that's causing it. It actually shows me that it's an app.js line 45. I can click in here and, okay, this is what's causing that stuff. I'll rewrite it, remove it, just think about how you approach this. Now, the last thought that I have on this is there are many ways that you can fix any of these core Web Vital issues or any of your performance issues. It's always going to be dependent on the technology that you use. For example, you could use server-side rendering to render the sale banner and everything else, and then just present that page to the browser. There are capabilities for this in React, in Vue, in Angular. Different frameworks would have different approaches to lazy loading, to make sure you don't have cumulative layout shifts and other things. So it's always going to be dependent based on the sort of framework and technology that you use. And one more example, cumulative layout shift so that, everyone is on the sort of same page with that. But I think it's very obvious what that cumulative layout shift is trying to do. What I have here, let me just check because I think I need to update something here real quick. So what I have here is just a paragraph, or a bunch of paragraphs. I need to remove this because I was doing some tests, and this. So let's serve this page as well. And you're going to see what this is doing. Oopsie. I need to enable this, right? So consider this page, your favorite news site. You start to read the article, and at some point in time, this happens. And you're like, what? I'm pretty sure it happened to you before, right? It's an advert just comes in out of nowhere, and now you have no idea where you were in the article, what section you were reading, etc., etc. So this is what causes you to get a very bad cumulative layout shift score. So in fact, if I just make the screen smaller, and if I refresh this page and I keep on scrolling, you will see that I'm in the green now, but at some point in time when the advert comes in, boom, this goes to red, cumulative layout shift of 0.2, that's already a big no. Now, for situations like this, again, there are different techniques that you can use. The easiest is just to have a placeholder. You have a placeholder for your advert. People will understand that there's going to be content injected in here. The content gets injected. Obviously, it's still annoying, but at least you don't lose track of where you were, and your cumulative layout shift is 0. Nothing changed, nothing jumped around in your content. Okay. hopefully there's going to be a way for you to get these resources, get the slides, and I collected quite a few resources for you. What I didn't talk to you about are images and media performance. Let me just do that as well real quick, because I think I have like a couple of minutes left. Consider the example for the watches, and I can show you that these watches were local assets, but let me show you an example using this particular watch. Now, consider that you have, and let's just, quick question. If I do this, does my screen zoom as well? Or it doesn't do anything? Am I just zooming locally? Okay, I don't know. I'm hoping you can still see this. So consider that you have an image, which is, you know, a really large image. If you take a look at the network panel, this image is nearly a megabyte in size. Now, what most developers do is that they take this image, maybe they run it through some sort of image, you know, transpiler, and then they use CSS to shrink it down. It's a much better solution to use image CDNs that are capable of, for example, adding different formats based on the browser for the image. So I'm just adding F-Auto and Q-Auto to the URL here. It's still going to generate me a massive image, but the size pretty much halved. And the reason being, this particular image CDN, Cloudinary, knows that I added the F-Auto flag, which is automatic formatting. And even though this is a JPEG, it knows that I'm using Chrome. So it's going to offer me a WebP image format, which is the sort of the best image format that you can run in Chrome, right? So this is already, with a very simple effort, optimizing your images, which is also going to help with your web performance, especially if you have a cumulative, a largest contentful paint. If it's a hero image, you just optimize your hero image, your LCP, your largest contentful paint time is going to go down significantly. Okay, so there are lots of tricks that you can do with media as well. And the reason why I said this, because there's a media speed test tool that I'm linking to, which goes through all your images and says, well, that image could be optimized, that image is good, etc., etc. Have a look at these, and I hope you will find an interesting resource in here. And with that, I forgot how to pronounce this, but I'll try. I think it's Hualv or something similar. Thank you very much for having me, and I hope you enjoyed this talk.